Well, on behalf of Reedley College today, I'd like to introduce myself and let you know how excited I am to be a part of the STEM Conference 2021. My name is Greg from the Greg and Dre Morning Show at Q97.1. Hopefully you've had a chance maybe over the years to hear me on the radio. My partner and I have been doing a radio morning show entertaining Central California now for 20 years. In May, we are celebrating our 20th anniversary on the radio. And it's something that excites me because I get opportunities like this. As someone that's in the entertainment business, I can have opportunities to be asked to be a guest and be a part of things like the STEM conference. And this is my 4th year now hosting STEM, and I am more excited than ever because last year, unfortunately, we couldn't do a STEM conference at Reedley College because the plan was to have it right when the pandemic got started. And of course, it left no time to be able to convert into a virtual meeting, which takes a lot of energy and effort. And I really appreciate all the people that have come together to make this event possible. And I mainly appreciate all you students out there that have wisely invested your time on a Saturday afternoon. This is, of course, nothing you had to do. Hopefully something you simply wanted to do or you were intrigued about. And let me tell you, you have made a very wise decision today to be a part of this. Now, I know your day has already begun with a lot of workshops and breakout groups, and hopefully those were really enriching for you. But in moments, I will be introducing our keynote speaker today, who I am actually personally fascinated to hear from today. And I had a sneak peek conversation with our keynote speaker earlier this week, and I was left with so many questions in my mind. But here's what I want to do. I want to set the tone as we get this started, because I'm going to ask you to be something today no one, I think, in your life has ever asked you to be. Okay? I want you to think about this for a minute, because when I kick off our morning show, me and my partner, Dre, we do a thing called the Greg and Dre Thought of the Day. And that's to kind of get our audience thinking, because with my morning show, we really have 2 goals. That being 1, get you laughing, and 2, get you thinking. So when we kick off the show and it's early in the morning, I like for everyone to get a thought in their head to get them thinking. And my thought for you today is, again, something new I'm going to ask you to do. And that is, I want all of you today, this afternoon, for the next hour plus, as we are going to have a fascinating keynote speaker come on, I want you to be a lung. What in the world does that mean? A lung. I bet no one in your life has ever asked you to be that. Well, let me throw out another term that maybe you're often asked to be, and that is a sponge. And a sponge is something that absorbs, right? And I think today in the breakout sessions, you did a lot of sponging, which is actually great. And I've asked people to be a sponge before. But I want you to be a lung in this regard. I want this to be a 2-way street today. This afternoon, I want our keynote speaker to have the opportunity to engage with you guys. So a sponge absorbs, and that's awesome, and there's a time to be that, but right now I want you to be a lung. So I want you to take it all in, take the oxygen in, the information, the insight you're gonna gather, and then I also want you to give it back, the carbon dioxide going back out, because this is gonna be an interactive opportunity for you. So we are gonna have questions, we are gonna have polls to get you to be a living, breathing member of this entertainment that we have for you, which is going to be very insightful. So I want you to be handy on the chat, on the screen, and I want you guys to not be shy. I want you to be a lung, a living, breathing member of this presentation you're about to get today. And I want to actually launch our first poll question right now, just to get you guys interacting, get you moving. Our first poll question, which is going to lead into our keynote speaker, is how big do you think a shooting star is? How big do you think a shooting star? One of those things that goes, woo, flies across. Hopefully you've had the luxury, the privilege of seeing one of those in your lifetime, and it lights up the whole sky. So dramatic. How big do you think that is? Answer the poll question. Let's get you involved and interacting there. And also in our live chat, I want you guys shooting questions out to us. A little bit later, you have an opportunity to win some prizes. So we got some questions coming your way. You'll answer, but we want to answer your questions. So we want you typing in questions. As soon as something pops into your head, feel free to type it in and you will get the answers today. So without further ado, it's my honor and privilege here to introduce our keynote speaker, who I am fascinated to hear from today. And she is Dr. Amy Mainzer, but let me give her a proper introduction, because Dr. Amy Mainzer is actually a professor in Lunar and Planetary Laboratory at the University of Arizona. It's one of the world's leading scientists in asteroid detection. And get this, everyone, she's a leading person in planetary defense. Now, I don't mean military, I mean a different type of planetary defense, which we are going to get into in just a minute. But Dr. Mainzer's resume speaks for itself. She has won so many awards, including the NASA Exceptional Public Service Medal for her work in near-Earth asteroids in 2018. She's also been a contributor and on-camera host of PBS kids series Ready, Jet, Go. So without further ado, it's my honor and privilege to introduce our keynote speaker today, Dr. Amy Mainzer. Hello.
Hi. Hey, nice to talk to you, Greg, and nice to see everybody here. Thank you guys for coming out on a Saturday to just, talk about some asteroids, rocks in space.
To just kick this whole thing off, when we hear something like planetary defense, I honestly get nervous. Should I be nervous right now about planetary defense as it relates to asteroids, Doctor?
Well, this is why we have astronomers and scientists all over the world who actually keep track of these things so that you don't have to be nervous and you don't have to, you don't have to go out and buy asteroid insurance. Let's put it that way. We keep watch on the skies.
All right. Well, we've got a lot to talk about. Luckily, we've got an hour to do that. Maybe I'll kick this off with the answer to our first poll question. And thank you. I see the students are out there. You're already responding to our poll. The poll question was, how big do you think a shooting star is? There were three options: a grain of sand, a refrigerator, a school bus. With 59% of the vote right now, the answer is a school bus. But doctor, just to kick it off here, so we see the whole sky light up, a shooting star, what is the size of that object?
The average shooting star that you see, if you see a flash, streaking across the sky, most of those are the size of a sand grain. They're tiny. Wow. tiny. And that's because, how do they make such a bright light? Well, they're just traveling really incredibly fast. And we'll talk a little bit more about exactly how fast. But the point is, a sand grain can light up the sky just like that. If you see a really unusually bright one, that might be the size of a pea. And that's it.
Okay. Wow. Now, see, this is where I get nervous, because if a grain of sand can light up the sky, I get incredibly nervous about things hitting the Earth. So I don't know where to begin. I can just say, as a novice in this, I've seen many shows about Tunguska, which is an event that took place in Russia way back in the early 1900s. Now, I'm just a layman, and that's all I know about what we believe is, and there wasn't necessarily great science back then to monitor these things, was that something may have hit the Earth and took out a lot of trees in Siberia. But that would be the way I would say, that's all I know.
Yeah, well, we do see a lot of evidence for impacts of asteroids and comets, sometimes on the Earth. And in fact, here, I've even got a little picture of that Tunguska event that you're talking about, just so you can take a look, so everybody can see this here. Basically, if you take a look here on the left, this picture right here, this is what happened over Russia in 1908. Look at all those trees. Ooh, whammo, just falling right over. And we think that what happened back then is that, even though, like you say, there's not a lot of great evidence that survives from this time period. This was in a really remote part of Russia, way in the forest. There was no internet. There were no computers. Basically, people just had to, there was an expedition that was sent out there after the fact. And these are some of the photographs they were able to take, some really precious photos. So we think what happened is that a reasonably small-sized asteroid actually came in and made it down through part of the Earth's atmosphere and then just exploded. And that's what knocked over all the trees. But we see lots of other craters. Mm-hmm.
You say small. I know there was evidence at the time that the light flash from this was seen, this was in Asia. The light flash from this was seen all the way into like Europe and across the Pacific. So that's what makes me scared. If that was small and the light flash was seen halfway around the world, wow, I'm nervous right now. I'm nervous.
Yeah. Well, let's put it this way. These things don't happen very often, which is great, because otherwise we wouldn't be here. We know that these things are pretty rare events. And so the question is exactly how rare. That's the question that I'm interested in answering, is just exactly how rare is rare. And what are we talking about here? So if we look on the surface of the Earth, we do see craters. In fact, here's one in India. And look how nice and round that is. It's even filled up with water at the bottom. This is a crater from an asteroid that impacted about 50,000 years ago. So that's a long time ago. Here's a really big one, so big that this picture actually had to be taken from space to really get the whole picture of it. And this is a crater up in Canada, and this thing's huge. It's 100 kilometers across. That is a really, really big crater. It's the size of a, like a big, it's a really huge area. But basically, this thing happened a long time ago. So that's the good news. So the good news.
I think now would be a great time to launch another poll question here, and that is, how big does a meteorite have to be to create a large impact crater? Because I'm getting nervous now. When I start seeing impact craters, I get nervous. The other reference point I have here would be the one that is like the dinosaur killer, right? The one off the Yucatan is, changed life on this planet forever.
Yes, it absolutely did. And I think this is kind of the sort of the big one, right? The really big one. So there's a reason why we're here on planet Earth, and it has to do with this asteroid that impacted. And this was about 65 million years ago. I got another little slide to show here just to show you just what this crater looks like. This crater impacted in the Yucatan Peninsula, so right off here in the Gulf of Mexico. And this was a very large impactor. This thing was big. It was a small mountain, basically, that crashed onto the Earth. And you can see here, you can actually even see part of the structure of the crater. We can see it from space again. Actually, part of it's under the water. And this was a huge crater. This was so big that it actually caused a global extinction event, meaning it really wiped out a lot of life on Earth at the time, including the dinosaurs. And in fact, most of pretty much anything that was a larger animal didn't make it. So part of the reason that we're here is because at the time of the dinosaurs, mammals at the time were little furry things that were kind of running around, hiding in holes, trying not to get eaten, presumably by the big dinosaurs. But when the dinosaurs were gone, that is what allowed us to become what we are today. I mean, if you can imagine, if the asteroid impact had not happened, maybe we would be lizard people. I think about that sometimes. Wow, boy, we'd be having a very different kind of conversation, wouldn't we? We'd be sitting on heat rocks, Maybe we'd be snacking on some flies or something. I don't know. But, it definitely changed life on Earth.
No question. And you work out in Arizona, and I know there's a very famous crater in Arizona. It might be a state park. I know visitors go to see it.
Yeah.
And tell us a little bit more, one that hit the United States that maybe is one of the more famous craters in the USA.
Yeah, so if you travel out to the state of Arizona, there is a crater here. You can see a picture of it. It's called Meteor Crater, real creative name. But it's basically a very, very well-preserved crater. The reason it's so well-preserved is this is the desert. So there's not a lot of, rainstorms or anything like that, or rivers or anything, or vegetation that would wipe it away. So it's a really good looking crater. We can really see it very clearly. And this one's about, kind of roughly 1 kilometer across or so. And it was probably about 50,000 years ago that this one was created. Again, not a terribly big asteroid that created this one, maybe about 50 meters across, give or take. But it's, you can definitely see it there. Big hole in the ground.
Yeah. Yeah, and I guess that then begs the question. I believe if we have the poll up now, we want all you students to take a guess at this. How big does a meteor have to be to create a large impact crater? That is our next poll question that I want you to take a guess. We have some different options on there, so please respond now, and you will be getting the answer shortly. Because I still am nervous here. I guess this goes back to an old school movie I saw. This is in the late 90s. It was called Armageddon. Maybe some of the students on here have seen it. Bruce Willis, Liv Taylor. It had some big stars in it, some star power. But the best plan we had at that time was to send oil riggers up and into space and try and drill a hole like they do to drill oil wells off in the Gulf of Mexico. So that made me nervous. If that's kind of our best plan, I'm very nervous, Doctor, right now.
Yes. Well, luckily we have we have better options than sending Bruce Willis up to
we do. Okay.
Yeah, we do. I mean, not that there's anything wrong with Bruce Willis. That he's great, no problem there. But we do have some better options, fortunately. And one of the most important things that we do is we actually go look for the asteroids. Believe it or not,
Oh, wow.
we really have to go find them. The first thing that we want to do is actually go look around and see what's out there and just see if we see any asteroids that look like they could be potentially coming our way. So that's a big part of what we do, is basically just go and look. And in fact, that's what I work on, along with a lot of my colleagues. We basically go out and we use telescopes, some on the ground and some in space, to actually go and search for these objects and then try to just measure some really basic facts about them, like how big are they? Your poll question here is a really important one. Exactly how big does something have to be before it really could make a big hole in the ground? Well, from our perspective, we want to know, are the things we're looking at big enough to do that? Or are they just small enough that they're mostly just going to be shooting star-like and we don't have to worry? So,
well, excellent job by the students here with some instant reaction on the poll. And the options were a whale, a house, half the size of a football field, or a car. And right now, the leading guess there from the students is a car. What is the answer? How big does a meteorite have to be?
That's a really, really, really interesting question. So it turns out that you need to have something that's about the size of a house to really make it down to the ground and create a hole. And it needs to be, kind of a large house at that. I mean, by the time something gets to be about, half the size of a football field, it will definitely make a crater in the ground like the one you saw in Arizona. So we definitely look for things like that. Fortunately, if something is as small as a car, it's going to make a big flash. It'll make a lot of noise. We might even find some little pieces scattered on the ground, but it's very unlikely that it's going to really cause too much damage on the ground. Our atmosphere is a really good shield, believe it or not. I mean, you can wave your hand through the air and it doesn't feel like there's anything there. But if you're moving as fast as some of these space rocks are moving, the atmosphere actually acts like a brick wall. And if it's small enough, it'll just smash into the wall and the atmosphere is actually going to blow it to smithereens. So as long as it's, kind of below that sort of house-sized or half a football field-sized limit, the atmosphere takes care of most of it for us. That's a good thing.
Now, how about in recent memory? Obviously, Tunguska was over 100 years ago. We talk about a dinosaur killer being, back at the dawn of time. Now we have, everyone's got cell phone video, technology age. Do we have recent examples of something coming down?
Yeah, so this is kind of an interesting thing that happened in 2013, give or take, in February of 2013, I believe it was. There was actually a really kind of unusual event that occurred. Now, I was driving home from the airport, actually, just going home, listening to the BBC radio, so the international news. And there was a news story coming out of Russia saying that there had been an asteroid that had exploded over the surface of the Earth over Russia. And I thought, that's impossible. The reason was because there was supposed to be an asteroid that was supposed to make a close approach to the Earth that day, but we were very sure there was no chance of it hitting the Earth. So it was really surprising. But as it turns out, this was a completely separate asteroid. So I have a few little clips of this here. And one of the interesting things about this is that now, instead of, unlike in 1908, when we didn't even have the internet or anything, here we have a lot of footage now. And this is probably one of what I would call one of the very best and well-studied impacts that we have ever seen for an asteroid. So it's really an important kind of thing. So we got a lot of footage here from people's, cameras and so forth, that they can see this really bright flash coming out over the sky. Security cameras captured it. And believe it or not, just from the angle of the sunlight that you see there shifting, we can use that. Astronomers use that to figure out the trajectory of the object, which direction it came from on the sky. So what happened is people saw a big, what looks like a trail across the sky. And then it actually took some time for the shock wave, the blast wave, to actually make it down to the Earth. So in other words, you could see the trail long before the wave actually made it to the surface of the Earth. And what happened at this point is that it surprised a lot of people because, there was just nothing predicted to be there that was supposed to hit. So basically, it was a pretty powerful explosion. It was not a large enough asteroid to create a big crater in the ground, though, fortunately. But it did break a lot of windows, and it surprised a lot of people because, again, we didn't have any prediction of it. So, yeah, and in fact, these poor guys here, they're just walking to the door, and then they have a big shock. That was a pretty good, strong shock wave.
Oh, my goodness.
Yeah.
Wow.
They get out the door. I'll tell you that now. They do make it out of there. But
and how big was the meteor / asteroid that caused this?
Yeah,
this
was thought to be about 20 meters across. So this is kind of at the house-sized limit, like a house, roughly. So not all that big. Wow. But in any event, yeah, so these guys, they did get out of there. A bunch of people did go to the hospital because of mostly flying glass, just because it broke a lot of windows. But nobody was hurt beyond that. So in general, this is why we want to ask the question, well, how often does this happen? And, what do we do about it? Or what are we doing about it? So from my perspective, the important thing to do is really go look for the asteroids. That's a really good start. So anyway, yeah, that's a little bit about it. What we when we talk about asteroids, by the way, it's kind of just worth pointing out what do we mean when we say these words: asteroid, shooting star, meteor. Sometimes you'll hear about meteorites. It's all the same stuff. It's basically rocky material floating around in space. If it's in space, we call it an asteroid. If it makes it into the Earth's atmosphere, we call it a meteor or a shooting star. And if a piece makes it all the way to the ground, we call it a meteorite. So just the same thing, just different words for it, basically, depending on what's happened to it. So anyway, like I said, they range in size from really small things to really big stuff. And
now here's a question for you. Back in 2013, did we or you or your team know that was coming, or did that just come out of nowhere?
No, that was a complete surprise, partly because This is a really small asteroid, actually. This one was only, like I said, about 20 meters across, so that's pretty small for the things we look for. And the other thing is where it came from on the sky is it came from nearly the direction of the sun on the sky. So in other words, if you're in daytime, when you think of telescopes, you think of going out at night and looking at the night sky. But the asteroids are all around us in the solar system, so sometimes they can come from the direction of the daytime sky. And this was an object that came from a direction that's really hard for us to look at because the sun's in the way and the sky is blue and bright. But we do our best. We try really hard to look for these things, and we're always thinking of ways we can do better to look for more of them.
Yeah, I want to launch another poll question right now, and we'll get to this coming up. But next poll question for all the students out there was, do you think there's been organic matter found on meteorites? So that would be life from outer space then impacting us here. And I think that'll be an interesting topic of discussion coming up. But let's get the students to react to that poll right now. Do you think there's been organic matter? That would be some sort of life from outer space that's made it down to the planet. So let's get those coming. And also, students, remember that you can ask a question and we can see those questions. And the brave soul, Isaac Serrano, thank you for asking the very first question today, Isaac Serrano. He said asteroids like the ones that killed the dinosaurs, and that is absolutely correct. And we discussed that earlier, but thank you, Isaac, for asking that question, being the very first student to do so. But we want to encourage all of you to go ahead and ask your questions. There could be a lot of them in your head right now, and please ask. And Dr. Mainzer is here to answer all those questions. So jump on the chat and we can see the questions coming in. We can ask those questions.
Absolutely. Yeah, I love questions. And by the way, the way I started with asteroids is I just found some people who knew about them and I asked a lot of questions. That is literally what I did. That, and I bought a book called Asteroids.
Well, there you go. Read an interesting concept. That's awesome. How about this? So how many of things that are flying into our atmosphere actually make it to the ground? How rare is that, or how often does that happen?
Yeah, so the good news is like I said, the atmosphere is like this terrific shield for most of the small stuff, all the dust grains, the little pea-sized things, really things up to the size of a car. One of my favorite asteroid stories, actually, is that there was a telescope here in Arizona that spotted an asteroid and predicted that it would hit the Earth in 24 hours. 24 hours. And so when the news got out, because we put all this stuff out really fast, basically everybody scrambled, the whole worldwide community scrambled, and about 500 astronomers contributed observations really quickly of this asteroid as it was making its way toward the Earth. Now, fortunately, this was a really little asteroid. It was car-sized. It wasn't much bigger than a typical car. So the good news is the atmosphere pretty much shredded it, but my colleagues were able to predict exactly where it was going to go. And it turns out it followed a track over the desert in Sudan. So not only were they able to see where it went, But they actually sent a group of students out from the University of Khartoum in Sudan with some meteoriticists, people who study meteorites, and they went out into the desert and they actually found the pieces of it. How weird is that?
Wow.
So they actually got the pieces. They saw it come in and they went and they got the pieces.
Retrieved.
Yeah.
A great time to answer the poll question then. And thank you all the students. You're doing a great job of interacting. And I do see your questions coming in and we're going to get to those in a minute. But has there been organic matter, AKA some form of life found on meteorites that have crashed to the Earth? 62% of the students are saying yes. Is that correct?
Yeah, so that's a little bit, we've given you a little bit of a trick question. This is a little tricky question. Okay,
trick question.
So, yeah, so is organic matter the same thing as life? And the answer is no, they're different. Life needs organic matter, but not all organic matter is living. But here's what we think we know. The interesting thing about how these objects form, the asteroids and the comets, is that they are formed from the very beginning of our solar system. So they come from right in the very beginning. In fact, I've got this little cool movie here that I think is really interesting because it shows just how do we get asteroids and comets, and for that matter, a solar system in the first place. It all starts with this cloud. And the question is, what happens to this cloud? There's gas and there's dust all mixed together. You can see what's starting to happen is the cloud's collapsing and forming a disk. Now, where does this get to the organic matter? Well, it turns out there's a stew of chemicals that are swirling around in this disk. The outer parts are colder, the inner parts are warmer. That's where the new sun is forming there, right in the middle. So the asteroids and the comets, especially comets, they come from the outer parts here where it's cold and where those gases can freeze, all that organic chemistry, all that good stew of complex molecules that life needs to get started. They froze onto the comets way out there. And so we think that what happened is that the very early Earth was bombarded by a bunch of asteroids and comets that probably did bring a whole soup of complex organic chemicals that life needs to get going. Now, I'm not going to go so far as to say that the comets caused life to happen on Earth, but they probably had some important role to play in the process. They brought the stew of things that basically make up, the bits and pieces that we are today.
Here's a question. Thank you. Sarah Brown has this question. It is, do you have any meteorite samples for your research? Do you have some at the University of Arizona that you are currently studying?
I have a very special treat for you.
Okay.
Here we go.
Yes.
I brought a little
got one. All right.
So this is a pretty special meteorite. This is one of my favorites. I know it's a little hard to see here. And if we were in person, I would try to have everybody around to, pick it up and touch it. But basically, this is what we call a palisite. And this is a type of meteorite that actually has a green gemstone all through it called olivine. So this is actually it's a birthstone. It's one of the green stones it's really beautiful. But basically these olivine crystals form inside of these meteorites. So there's all kinds of interesting meteorites that come to the Earth. And in fact, we do work on them at the University of Arizona. There is a really spectacular meteorite collection. And some of my friends here actually have this really super duper microscope, which is just perfect for looking inside of these little crystals to figure out exactly what kind of soup of interesting organic chemicals are stored and captured inside of these crystals. So yeah, once you get hooked on meteorites, they're pretty fascinating, I think.
And here's another great question, this coming from Richard Mendez, and I think this is food for thought. He says, is it possible that the life / organic matter might have been alive, but then die as it's burning in the atmosphere? Is that it could have been alive before it hit the atmosphere?
Well, it's pretty hard to rewind the clock to 4 billion years ago or 4.5 billion years ago when all of this happened. But so far as we know, let's put it this way. Today, we have no evidence that there's anything alive on the surfaces of the comets or asteroids. We just know that we see really complicated chemicals that are what we would call the kind of the pre-ingredients for life. If you're mixing up a cake, right, this is sort of like finding some flour and some eggs out there, but it's not the same as finding a whole cake. So we're not there yet. We have never seen direct evidence that there was ever anything like bacteria or anything like that on comets or asteroids, just the precursor chemicals. That said, that's really exciting right there from my perspective, because it says that actually maybe it means that life could have come to be somewhere else in the universe. And maybe it's not just here on Earth. Maybe there are other places out there that are nice places like this one. One thing I will say it does tell me, spending all this time looking at rocks in space, that this planet is incredibly, incredibly special. I mean, you know, there's no place else that has donuts and popcorn and oceans and, you know, and bad TV and all the great things that really make Earth wonderful, right? And friends. I mean, this is pretty special here. The rest of the universe, as far as we know, isn't like this.
Now, just last week, it made the news. There was a near-Earth flyby, and I'm sure that's something maybe you're aware of. I guess it's not exact science. They weren't exactly sure would it hit, would it not hit, but the word was it came so close it flew inside the satellite layer that is going around. It went inside our satellites. Is that correct?
Yeah, there are these really close flybys every now and again. They actually can be so close. They do, in fact, come under the ring of the highest orbit of satellites that surround our planet. These are generally pretty small objects, which is the good news. But, you know, we definitely have to keep an eye out for them because, like you said, when we first see an object, we don't know very much about it. It's new. So we have to watch it. And in particular, we have to really watch where it travels and try to get lots of different observations of it over time. That helps us build up a better knowledge of exactly where these things are going to go. So the race is on from our perspective to try to really not just find them, but keep tracking them as well. And so for an object like this, we got to, you know, we keep watching on it.
And how much advance notice would we potentially have? I mean, what if the house-sized meteor asteroid is headed our way? How quickly out do you pick it up, or your team or the group of scientists that are working on this? I mean, are we talking a year in advance? Are we talking a week in advance?
That's a really good question. So, well, so the goal of our surveys, we really ideally want to find these things when they're decades away, right? We want to find it, you know, when it's not just a year away, but when it's, you know, 10, 20 years away, something like that. That said, we do our best, and we found a lot of the really big asteroids, you know, the things that are big enough to cause those global impact problems, like the one that wiped out the dinosaurs. We think we have found about 95% of those, the really, really, really big ones. We think we found almost all of those. And when we've been watching them, they're not going to get anywhere close to the Earth that we have to worry about. For the smaller sized objects, though, to be honest, we just really don't know where most of them are. We still haven't found the majority of them, which is why this is, in my opinion, still something that's worth doing. We need to go out and we need to look for the rest of them. Ideally, we're going to find these things not when they're a day away from impact, but when they're, like I said, we want to try to find them when they're years away. So we've done a lot of work to find the really big stuff, which is really important because that's the stuff that can cause, you know, really big problems. But when it gets down to the kind of more medium-sized objects, we still have a long way to go to find the majority of those. And for the house-sized objects, you know, we got to just keep looking.
Now, I am aware that we have what's referred to as an asteroid belt in our solar system. So when you say you're trying to identify these, are you looking in the asteroid belt, or could you give us more information about what the asteroid belt is, or how big of a threat that?
Yeah. Let's talk a little bit about like just what's in our solar system here. I mean, I'm talking a little bit about this, but let's kind of look at a map. How about that? That might help clear things up a little. So the nice thing is I've got this handy map here of the solar system. And I don't know if you guys can see this, but basically what we're looking at is, imagine you're floating out there in space looking at our solar system, and the sun's here in the middle. Then we've got, you know, Mercury, Venus, Earth, our favorite planet, my favorite planet right here. Then we've got Mars, and then we've got Jupiter way out here. And all of these little speckles that you see are asteroids. Now, when you talk about the asteroid belt, that's this part right here, all these green asteroids, all these little green dots that are between Mars and Jupiter. That's where most of the asteroids in this inner part of our solar system really are. They're mostly in this belt between Mars and Jupiter. And that's great because they mostly just stay there and they never get anywhere close to us. And if they ever start to move it out into different orbits, it takes them millions and millions of years to change their orbits. So most of the time, we don't even worry about these ones. But here's the ones we do pay particular attention to, right in here, these little red dots. We call these ones the near-Earth objects because they do start to get a little closer to the Earth. This is the population of asteroids and comets that we really watch carefully. And like I said, we're really trying hard to find and track as many of these as we can, so we can just keep track and make sure that there's nothing out there that, you know, we need to get Bruce Willis and his oil drillers to go, you know, drill or something. But that said, we really do have a lot of work to do to go find these objects. We're working on it. And we've even been thinking a lot about, how would we potentially push one out of the way that's not Bruce Willis? And so there's been a lot of serious effort to try to think about that part of the problem too.
Yeah, well, let's get to another question, if you don't mind. Pedro Herrera, thank you, Pedro. And all of you, again, be a lung. Breathe it in, breathe it back out. Ask the questions. Thank you, Pedro. He's asking about a specific asteroid, and I may blow the pronunciation here, but Umamahu, I think it's a Hawaiian name.
Yeah, Oumuamua. And this is
there
one
we
of my
go. Sorry.
favorite asteroids. Oh, I'm so glad you brought this up. This is one of my favorites. Okay. This is an object that's not from our solar system at all.
Wow.
Came from somebody else's.
Came from nowhere.
Yep. It just decided to come from somebody else's solar system, and it made its way here. And it just passed zipping through our solar system, and it's on its way back out again. We were just very lucky. Astronomers were really, really, really lucky to see this object because it's so rare that these things, in fact, we only know of one other object now that's been found since the discovery of Oumuamua, basically that has come from another solar system entirely.
Wow.
So a rare visitor from the, deep, dark depths of space, basically.
Wow, that is amazing. So, the world is so big. I mean, the universe is so big, and we've explored so little. I did find it interesting, though, on Mars, because we just had the helicopter on Mars, which was amazing. And I saw some of those views, and it just, from what we saw, it looked like a desert, but it looked like there were meteorites all over the surface. Like it was amazing. It was.
Yeah. One of the funny things.
Because they have less atmosphere there, or I don't know.
Well, so it's pretty good bet that there are meteorites that have hit Mars. But the funny thing is, Mars has actually sent meteorites to us. We actually have meteorites just like this one, except they're from Mars. And we're sure of it because we can tell what they're made out of. We have them, we can put them in our labs, and we can study them up close. And we have rovers on Mars that can study the rocks there, and you can tell it's a match. So we actually have, believe it or not, they're very rare, but we do have some. They're Martian meteorites. So Mars has actually been occasionally, we think what happens is that a big asteroid comes, hits Mars, and a bunch of little pieces fly off, and some of them actually make their way here to Earth. It's pretty amazing.
Wow, that is. Another question coming, thank you, Andrew Brigus, who says this: is there anything else other than dry ice in asteroids, like metals, etc.? If so, does the magnetic field factor repel them?
Oh yeah, so this is a really cool thing about asteroids and meteorites. When we get them on the ground, we call them a meteorite. But basically, they have all kinds of interesting things inside them. There's, if you look at all the different kinds of rocks that we find on the Earth, we see a huge different range of rocks among the asteroids and the meteorites as well. We see some that are crumbly and fragile, almost like if you were to take a snowball and kind of mix it with mud and then let the snow melt, and you kind of just have this crumbly thing left, all the way to things that are basically just solid lumps of metal. So there's a huge range of different kinds of objects that are out there. A lot of them do tend to have a lot of metal in them. They tend to have lots of nickel and iron. And so one of the classic ways of figuring out if something is likely to be a meteorite is it magnetic? Does it respond to a magnet? Will it get attracted to a magnet? So there's a lot of different kinds of interesting meteorites that are out there. And in fact, the one that made the big crater in Arizona, we're pretty sure that one was mostly made of nickel and iron because we found little pieces of it all over the desert.
And what is the likelihood of something actually hitting the planet as opposed to blowing up in the atmosphere? And what would do more damage?
Yeah, so we think that it's, the bigger the object, the more potential damage it could cause on the ground. So we definitely want to start and find those biggest objects first. And that's kind of what astronomers have been doing. We've started looking for the really large stuff and then kind of working our way down in size. We definitely want to find the things that are large enough to cause, big holes in the ground for sure. And we really want to try to find ways also to push them out of the way if we ever needed to do that.
Yeah, and another question here: does the asteroid belt act as a protective shield from other dangerous objects that have a trajectory heading towards us, or could we be in more danger if two things collide and then they could send things towards us?
Oh, that is an interesting one. So the good news is if something's in the asteroid belt, it mostly won't make its way here for maybe tens of millions of years at the earliest.
Oh, wow, okay.
If something's in the asteroid belt, we don't have to worry about it. And insofar as people are concerned, they're safely away from us. That's the great news. Good news is But I mean, stuff does leak out of the asteroid belt and eventually gets into the inner space, or it can get into the space near the Earth, but it takes many millions of years for that to happen. So not to worry about the asteroid belt. But it is an interesting question. Do asteroids collide? And it turns out they do. They absolutely do. We know that collisions happen in the asteroid belt because we've seen it with our telescopes sometimes. And we can even see inside the meteorites we pick up, you can even see cracks that show when rocks have crushed together and actually shattered pieces. So we know that they definitely collide in space. And that gives rise to something, asteroids actually have families, believe it or not. They actually are called families because when an asteroid collides with another, it creates a big shower of pieces that all are kind of going around the sun in the same path, more or less. And we call that an asteroid family. That said, sometimes we get asteroids that have binary pieces. So in other words, they have little moons all their own. Asteroids can have moons. That's another interesting thing. And sometimes we see craters even on the surface of our moon and even a few on the Earth where it looks like it was an asteroid with a moon that hit and it made a double crater, boom, boom, right next to each other. So there's definitely a lot going on out there.
Now, how good of a shield could the asteroid belt be? How dense is it? I mean, is it something that is a shield? I mean, are there asteroids everywhere? They'll stop anything. It's a great line, like a bulletproof vest, or how
yeah.
the asteroid belt?
Yeah, so let's see, if we were zooming around the asteroid belt right now, okay, imagine if we could go fly to the asteroid belt in our spaceship, in our imaginary spaceship. This is really pretty much what it would look like. It would look like dots.
Oh, wow.
What it would not look like is this.
Oh, yes, the Millennium Falcon. There we go.
Okay, remember, I don't know if anybody remembers.
Right there, yes.
But the Millennium Falcon is cruising through all the asteroids. Well, no, it would not look like that. If we were sitting on an asteroid in the asteroid belt, it really would just look like a bunch of stars, almost all of them, because space is so big. Even though we saw all those little green dots swimming around in the asteroid belt and it looks like they're really close together, if we were out in space looking out with our telescopes ourselves, we would mostly not see big chunks of rock floating right next to us because space is really huge. And so even in the densest part of the asteroid belt, it would still pretty much look like dots.
Darn, I was really hoping it was like the Millennium Falcon, Han Solo.
I know. That would be awesome
for us, wouldn't it? If we can move a little closer to home now, and more of a modern movie that concerned me, because Armageddon was a long time ago, but more of a modern movie was Gravity, where you have the astronauts in space, and it really wasn't something coming from another solar system, the asteroid belt. It was our own planetary debris that was wreaking havoc. So how big of a problem is things that are man-made in space presenting?
Yeah, that's a really good point. So, basically one of the things we've learned, like I said, one of the best things I think about doing astronomy is it really does give you a great perspective on how special Earth is, because this is it. And we really have to protect our home planet. Rocks don't have movie theaters and popcorn and all the fun things that we really like, right? They don't have that.
Yes.
But the thing is even in space, we have started throwing trash, unfortunately. We have been polluting space, just like we've been polluting the ground. And it turns out our Earth is now surrounded by a cloud of debris that people have put up there. The problem with stuff in space is a lot of times it just tends to stay. It doesn't go away. So that actually creates problems for our other satellites, our telescopes that we put up, things like that. We have to watch now and be very careful to make sure that we don't actually run into the space junk that's up there. So yeah, that's one of the things we got to work on, is trying to make sure we don't leave more junk up in space, just like we have to protect our planet here on the ground as well. Got a lot of work to do.
Here's a great question again from Sarah Brown. And by the way, jump on the chat, everybody. This is a fully interactive program with Dr. Mainzer. So jump on and ask your questions. But I think this is a great question. Is there a way to clean up space debris? Have we been working on that type of technology yet?
That's a really, really important question. And I hope more people will think about it just like you are, because yeah, they're thinking about it. But of course, one of the very best ways to clean it up is not to put it up there in the first place, right? In other words, try to not do things that create the junk. So one of the things people are trying to think about is how can we make sure that anything that we do put up really does come down and safely burns up in the atmosphere. That's not a complete answer though. And we definitely need to think of new ways to get rid of what's already there that hasn't come down yet. I haven't personally worked on that myself, but I can show you a picture of what some other satellites look like in space from my space telescope here. I got a picture for you. So let's take a look here. This is a picture taken by a space telescope that I work on that's orbiting the Earth. It's called NEOWISE, for NearEarth Object Wide Field Infrared Survey Explorer. I know that's a long name, but basically this is a telescope that's orbiting the Earth. It's about 500 kilometers off the surface, and it goes around our planet about every 90 minutes looking for asteroids and comets. But take a look at these streaks. If we look up into space, okay, does anybody want to take a guess as to what these are? Are they? What are they?
Looks like a shooting star to me, but
do you think they're raindrops? Right? Could they be raindrops? No, they can't be, right? Because we're up in space and there's no rain.
Could be.
But you know what they are? They're other satellites going overhead of this one.
Oh, wow.
So we're a satellite looking up at other satellites going by. And so you can see there's a lot of stuff up there in space that's orbiting our planet. That we also have to pay attention to. So yeah, there's a lot going on. Of course, one of the great things about using a space telescope is we get all kinds of really fun pictures, like this one here. This is one of my favorites because you should try and spot the asteroids. They look like little strings of dots. There's an asteroid going right by. I'm taking lots of pictures of it here. And what I've done is I've kind of added all the pictures together so you can see the asteroid kind of moving through space. But basically, there's a little string of dots. That's an asteroid. Oops, here's some more dots. Look at these little orange dots. There's one. And oops, here's another one. They're all over. In fact, in total, I counted one time. This image has about 100 asteroids passing through it. But it's also got a lot of cool stuff, too. Here's a star cluster. These gas clouds, these are a place where new stars are forming, like this one right here. That's a baby star. And there's also stuff that's much more distant that are, things that are galaxies that are very far away. So anyway, we see all kinds of fun stuff.
I think this is the burning question on my mind. And I want to thank Javi for asking the question, because it's one thing to identify them. It's another thing to then defend against them. So that is
right.
From Javi. Thank you, Javi. How can we defend Earth from asteroids? What can we do? Where's the research?
Yeah, that's a really important thing. So the first thing, like I said, is we got to find them and find them early. So we have lots of time so we can build spacecraft that can go out there and push them out of the way. So if you do that, then the next step is, depends on how much time you have and how big the asteroid is. If it's a really big asteroid, you need to hit it with a lot of energy to be able to push it aside. But ideally, if you have enough time, you don't need as much energy to push it just a very little bit, and it will still miss by a wide amount. So that's why we're so interested in surveying for them and finding them well in advance of any potential close encounter. There are multiple ways, if you have enough time, that you could try to push the asteroid out of the way. The simplest thing is to just simply bump into it. Boop, like that. We call that a kinetic impactor, which is just a fancy way of saying we bump into it. So basically, you try to put a little spacecraft up there and you hit the asteroid as fast as you can and try to nudge it so that you change its orbit. That's one option. Another thing is you take a spacecraft that's as big as you can make it, really, really, really big. And then you park it next to the asteroid and you let the force of gravity slowly pull the asteroid out of the way. That is called a gravity tractor. But as you can imagine, that takes a while to work, we think. So there are other options that are more and more and more severe, but basically they all depend on us having enough time and knowing enough about the size of the object. So that's what we're really trying to do here is, give us lots of time so we can go out and make a mission that we're really sure is going to do the job if we ever need to do it. Remember, there might not be any impact in our near future in our lifetimes. That would be the best case answer. And that's quite possible that that's true. But right now, we're not entirely sure. So that's why we go look.
Now, I think of anything we send up. I consider us in the vast scope of the solar system, the universe, being rather puny. And anything we send up is like small potatoes. So is there the possibility of hitting it with, say, like a nuclear weapon or something along those lines, something with extreme force?
Yeah, and actually scientists have really thought carefully about this. And we have looked at all these different options. And really the thing we want to do is the simplest thing, because it's the easiest to build, it's the most likely to work, it's the simplest possible thing. The simplest thing we could do is just that kinetic impactor idea where we bump into it. And in fact, there was a NASA mission that was sent up in around 2004. It actually went and it hit a comet, and it actually bumped into the comet, and it made a big crater on it. And so we actually could see that we were actually able to make a big crater on a comet, a pretty large one. There is another asteroid that was impacted not too long ago, in fact, by the Japanese Space Agency. They sent a mission called Hayabusa 2. It went to an asteroid, it collected a sample, it actually got pieces of it, and it has brought it back to Earth already. It also created a crater. It actually gouged a crater on this asteroid, and they were able to look at it. So in other words, we have been doing tests of these kinds of experiments where you can actually bump into an asteroid and see if you can, make something happen to it. Looks like we can.
Follow-up question from Bethany Ray. She says, how do you determine the trajectory of an extraterrestrial body, and what margin of error would there be in pushing a meteor off course in the event it got hit?
Boy, this is really important. So when we first find an asteroid, we really don't know where it's going. We just see that little string of dots kind of marching across the sky. So the first thing we have to do is connect the dots and calculate an initial orbit for it. We want to know, is the object nearby or is it far away? So that's the first thing we do. Then the next thing we do is we wait a little time, and then we try to get more observations of it so that we can see its path across the sky much more clearly. It's kind of like if you throw a ball. When you throw a ball, if you're going to try to throw a ball to someone and you want them to catch it, when you throw the ball, you kind of watch it with your eyes, and your brain instantly does this mathematical calculation, whether we realize it or not, that tells us where the ball is going to go. This is what we have to do with the asteroids. We have to watch them enough so that we can calculate exactly where they're going to go. In order for us to be able to tell exactly whether the asteroid is going to get close to the Earth, we usually want to watch it not just for a day or two, but we really want to watch it for years, months, months to years, to really pin down the orbit. And that is what tells us enough information that we can make really high precision calculations about whether it will miss the Earth and by how much. So that's what we have to do. We really have to watch them. It's a lot of work.
I think a great question, because you have so much information, Dr. Mainzer, and this topic is so fascinating. And just me personally, I know I'm learning a lot, and I hope the students are as well. But I think this is a great question, considering we're at the STEM conference and there's a lot of bright young minds that are trying to figure out their future. And I want to thank Fatima for asking this question. She says, how do you become an astroscientist?
That is a really great question. And I love that question because, it starts with just being interested in science. It starts with just being curious about the way that the world works. And that's the most important ingredient. If you care about it, if you're interested in it, that's what you really need. That's the fundamental key ingredient. That's like the magic secret sauce. If you are interested in this, you can go off and get started on the path toward doing this kind of work as a professional. I think the key thing is you want to study and read all you can. Read lots of books. Just because people think that if you do science, that means you never read or you don't write. But that's not true at all. We're constantly reading and writing. So read books, write a journal, just all the things that you can to practice talking about the things that you learn. And then, of course, we do study a lot of math and we study a lot of science. In my case, I went off and I actually became a physics major when I went away to college. And I studied physics for 4 years. And then after that, I went on to graduate school. And there I did a PhD in astronomy after that. And now I study planetary science, which means I look at space as well as the Earth. So it's a lot of fun. I will say this, it's a really great career because you can never, ever get bored. It's impossible to get bored if you study science. It's just, there's always something new and interesting that's happening. And it really keeps your attention. Every day is different than the next.
Yeah, I think too, it would be great if you could expand a little bit on some of the difficulties you've run into, because, especially for a young mind out there, and hearing you talk, and you have so much information, so much insight, years of experience doing this, but when you're that young mind and a teenager and there's difficulties and challenges, that arise in your life that you have to overcome. Can you expand on some of those challenges that you ran into and explain how you overcame them?
Yeah, I think about this a lot, and it's funny because it just seems like it was yesterday that I was starting college and starting graduate school. It seems like the time goes by really fast. But the thing that I noticed about this as a working professional scientist, I can honestly say the classes are not necessarily representative of what it's really like to be a real scientist. The classes, when you do them, sometimes it seems like they can be very sequential. So in other words, when you're learning math, you have to learn math in a certain order. You have to learn to add before you can multiply. And then eventually when you start learning calculus, well, you need to know algebra before that. And it really helps to know geometry. So each step of the way is that there's an order to learning things in math, that it can be very difficult, because if you get stuck on one part of it, then you can't go on, and you have to get unstuck first. So that is kind of part of the difficulty, I would say, that the classes are sequential, but the thing is, their real life as a scientist is a lot different than the classes. For one thing, it's really about solving problems. And it's about solving problems with your friends. You find people that you really like to work with, who like to think about the same kind of problems you're interested in, and then you work together to solve them. So it's a lot of teamwork, it's a lot of joking, it's a lot of laughing, it's frustrating sometimes, but it's a lot of fun. And I know everybody's had the experience in class where you think, oh boy, this homework is just really, it makes me so tired, and I don't get it, and I'm frustrated. Real science is different. If you are stuck, you go talk to your friends and you try to figure it out together. It's not lonely. In fact, if anything, it's a lot of fun, because you're constantly working with people that you really like. So I would say one of the challenges is kind of recognizing that, oh wow, I have to get through these classes, and sometimes I get stuck on the math, say, or on a part of the science. But if you can just kind of be patient with yourself and find the teachers who are helpful and who are nice to you and who will help you get past being stuck, there's a whole big world out there that's a whole lot of fun, and there's tons and tons of interesting and really important problems that you can contribute to, that you can solve if you work on science or engineering or math, any of these subjects. They're really important, and they're a lot of fun.
And what would you say, as someone that works in the field of STEM, obviously you spent your career in it, and all the students on here are now considering it, and they've been filled up with a lot of information on possible careers and things that hopefully inspired them and got them interested today. But what would be your take? What would you say it would be, make it an important line of work or important career decision to move into a career in STEM?
Well, I was kind of talking about this a little bit earlier, but as you know, there are a lot of problems here on Earth. We've got problems with pollution, with climate change. The Earth is getting warmer because we're putting a lot of pollutants into the atmosphere. We need a lot of smart people to help figure out these planetary problems. We really do. We need some of our best and brightest to really help us figure out how to solve it. And the good news is that there are things we can do. We absolutely can fix these problems, but it takes a lot of effort, and it takes a lot of smart people. We need all the smart people that we can find to go out and figure out how to solve these big problems. So if you're interested in trying to solve problems that they really do need working on, this is a way you can contribute. You can help.
And another technical question here we'll go back to, and thank you to everybody who's been chiming in. You guys are doing a great job with the questions. And it says this: could the ISS, International Space Station, be used as a launching pad for a device that could help in planetary defense?
That is really fun. Yeah, actually, so it turns out we have looked at using the space station for some of these experiments. And in fact, we even looked at putting a little telescope on the space station just to look for asteroids and comets. We ended up not doing it because it turns out the spacecraft that we have right now that's orbiting the Earth is doing most of that kind of work that we'd be able to do from the space station. But one of the cool things the space station is doing is it's looking down at the Earth. And it's contributed a lot of really important measurements, in fact, of some of the greenhouse gases like carbon dioxide that are causing our planet to heat up. Those measurements are being monitored from a platform called the Orbiting Carbon Observatory 3 that's mounted on the space station, and it looks down. The reason I know about this, is because the cameras, the very same cameras, the kinds of cameras that we use, the chips that we use to look for the asteroids, we can also use to look down at the Earth. So in this case, we're not using the space station platform for looking for asteroids, but we are using it to look for a lot of other important stuff too.
Another question, and thank you, that was Alejandro Perez who sent that in. Thank you very much for that question. Another question too would be about mentors, and potentially a lot of the students that are on with us today are maybe first generation to the country, and they're seeking out mentors. What advice would you give the young person out there, the middle school, the high school, early college student, in seeking out a mentor to help guide them along the way getting into a STEM career?
Yeah, I think, one of the best things about going off to college, in my opinion, was that you kind of find your friends, you find your people, you find the people who are interested in the same things that you are, and you can talk to them about all kinds of neat subjects. You can try new projects, you can try new research. I think a big part of this is finding just, the people who are around you in class who are also interested in all these kinds of things. So finding your friends, that's an important thing. And friends are great mentors, I think. Some of the best mentors I've had have just been, friends of mine, people I knew from school and work, and just really, we were able to support each other and help each other out with homework sometimes, or, just things like that. But also too, I think just in general, it is really important to just find people who are kind to you and who are willing to spend some time. If you have a teacher who is willing to talk you through, like if you get stuck on that math problem, find somebody who's willing to help you figure out exactly what it is that makes you stuck. A lot of this it's about finding your friends and finding the people who, really like the same things that you do, and just remembering that they are out there. Sometimes it takes a while to find them, but they're there. And when you connect with the people who appreciate you and like you for who you are and the things that you're interested in, it just makes a world of difference. And I think that, to me at least, was really important, to be able to find the people who I knew were also interested in science and who didn't think it was weird, or if they thought it was weird, we all were weird together. That made a big difference. And those people are out there. That's why you're here.
Your expertise has also allowed you to get into other opportunities like the PBS show. And was that something you always wanted to do also, was to be on camera, be a part of the media? Did you stumble into that?
Yeah, that's a funny thing. That was kind of, I was always interested in science starting when I was a kid. And I knew that I was interested in science when I was really, really little. But, middle school was kind of a tough time, and I'm sure it is for a lot of other people too. But basically, it was definitely kind of, if you were interested in science in middle school, where I went to school, you were weird. Absolutely. So
there's nothing wrong with being weird, by the way. I consider myself very weird, and I'm proud to say I'm weird. I'm a nerd, and I'm okay with all that. So
yeah, I am a proud nerd.
Yes.
Absolutely. So, that when the opportunity came to work on the kids show with PBS, it just really, that was something I really did want to do, because I remember what it was like to fall in love with science as a really young kid and think, wow, this is really fascinating. So it was a lot of fun because it's great to connect with kids. Kids are natural scientists. They just are. They ask questions without fear, without being worried about feeling like they're being silly or anything like that. They just ask. If you don't understand how something works when you're little, you just ask. So I think that's one of the things that is really neat as a professional scientist nowadays. If I don't know something, I just ask. And that's my job, actually. I love it.
This is a great question. This is a really great question. Misbah Khan has this question for you. What was the first thing you discovered when you became an astrophysicist? Do you remember?
Ooh, well, it's a lot of different things that you start to figure out. And I would say one of the things that I'm happiest about is we did get to discover a lot of asteroids and comets with this space telescope I've been working on. And one of the neat things about doing that is we get to name them sometimes.
Oh, wow. Okay. So have you named one after yourself, or maybe your favorite fur baby? Or
well, someone named one after me, which was really nice.
Awesome. So where is your asteroid located, or how far out is it? No,
Fortunately, I am far away from the Earth and I have no chance of hitting the Earth.
no chance. Okay.
So I am way safely in the main asteroid belt, way, way, way far away from the Earth. So
Yeah, because it's fun until you become notorious, right? If your asteroid was the one headed this way, then you're in the no fun zone now.
Yeah, exactly. Exactly. So one of the things about NearEarth objects is we never name them after people. We only name them after mythological characters. The things that get named after people are safely well away from the Earth in the main asteroid belt. So that's where I am. I'm off floating in space somewhere very far away.
And Susanna Cruz is very interested to know the answer to this. She says, are you a NASA scientist?
You know, I used to work for NASA's Jet Propulsion Laboratory in Pasadena, California, and I worked there for quite a while. I was there for a long time. I had a great time there. I got to work on several different spacecraft while I worked there, so different space missions that NASA did, and I loved it. I had a great time. I got to build pieces of things that are in space, and that was really exciting. It was really, really fun. After a while, it became possible to come here to the University of Arizona, and now I'm a professor. So it's a little different in some ways, but in a lot of ways it's very similar kind of work. So I'm still getting to study planetary science and looking up and looking down. In fact, I have a new project that's going on right now, right as we speak. I am working on a project that's on an airplane that's using a camera and a laser to look down at the Earth and try to make maps of some of the forests in Southern California, so we can look for invasive weeds that cause these wildfires that we've been having.
Wow.
So in fact, I can even share the little screen here with you, and you can see the airplane. Here we are making our map, going across the forest. Look at that. There they go. So yeah, so this is the kind of stuff you get to do if you're a scientist. I mean, I really love this stuff, because if there's a problem that's interesting to you, there's something you care about, you can try to go work on it and try to go solve it. And you work with your friends. That's the best part.
That is so interesting. And I think that's the great thing with STEM. Really, the sky's the limit. As you get into it, you can chart your own course. You can find new and different things to research. They're kind of the sky's the limit, wouldn't you say?
I would say in some cases, the sky isn't even the limit.
The sky's not the limit. Wait a minute. You're right. Oh my gosh. Yes.
Past it. Go out in space. No, there's all kinds of cool stuff you can do. I mean, and I think the thing that I really enjoy about this is that you can make a difference with things. You can try to solve some problems that you can't get at otherwise. You work with your friends. It's never boring. Oh my gosh, there's always something new and exciting that's out there to learn. And whether it's asteroids or plants or bugs or fish, whatever it is, there's something cool out there that's waiting to be discovered that nobody else knows. Or there's a problem that needs solving that you might be able to figure out how to fix it. I think that's what's really cool about it.
And here, maybe if for the high school or college student that's out there asking this question, did you get started with an internship in college?
Yes, actually. So for folks who are in college or thinking about going to college or thinking about graduate school, even the next step beyond the bachelor's degree, internships are really important, and they're a great idea. I would say there are, for example, within the space community, there are internships that are paid. So in other words, you actually get paid to go off and learn to do research with a scientist or a group of scientists or engineers. Those are really important experiences, because remember how I was saying, the classes aren't like the real work. They're just not. They try. The classes are a really efficient way of kind of funneling knowledge into your brain really quickly. But it's not the same thing as working as a scientist or as an engineer. That's where the internships come in, because now you get the experience of what it's actually like to do the job. In other words, how do you work with people? What kinds of problems do you decide to solve? Going to lunch together, you know what I mean? And talking about your problems, the things you're working on. How do you solve problems together as a group, as a team? That's, I think, the important stuff about internships, is they really help you see not just more about a particular subject, but they teach you what it's like to be a person actually working in STEM. And I can tell you, it's not like the classes at all. Classes are way less fun. And they're just there to get information in your head. They're not what the real work is like. Real work is really different.
And so I started off this introducing you with a little bit of fear, Earth defense. I was scared. But as we sit here today, and all the students listening, are we feeling in the scientific community like we we're okay for the next few years as far as something large hitting the planet, that we can at least rest assured tonight when I go to bed? Would you say that's accurate?
Absolutely. Like I said, you don't need to buy asteroid insurance. That's why we have a space program.
Okay. I'm not going to worry about it.
That's what the space program is for. And that's actually what we do. So we go out there and we keep an eye on this stuff so nobody else has to worry about it. It's not something you got to worry about every day. There are other problems that we definitely do. And that's where it's important for scientists and engineers, mathematicians, all kinds of folks have to work together to try and solve some of these tough things that we do worry about every day. We're living in a pandemic. I mean, that's a real eye opener. And if nothing else, that's really shows, it just shows everybody the importance of working on these kinds of topics, science and engineering, medicine, math, all of it, because that's what helps us solve these really tough problems when they come up.
Yeah, and maybe some of the students that have been on with us today, they pick up the baton like a track meet from you and keep us moving forward in the area of Earth defense. The next young minds could be the next ones solving a very difficult problem. But Dr. Mainzer, I want to say thank you on behalf of Reedley College, all the students here, myself. Wonderful information today, very entertaining. Thank you so much for taking time out and educating us on something that frankly is necessary and exciting. And it involves all aspects of STEM. Of course, we really appreciate all your time today. Thank you so much.
Thank you. It's really been great to be with all of you. And thanks for all your fantastic questions. I really appreciate them.
Awesome. Thank you very much, Dr. Mainzer. All right.